recording the session. We are good to go.
Thank you, Aisha. Thank you, everybody, for hanging with us in the technical difficulties. We're starting a little bit late, but welcome, welcome, welcome. We are really glad to have you. Really glad to be here with you today. I'm Bianca Mobius-Clune, Director of Climate and Soil Health here at American Farmland Trust. And I want to send a warm welcome to those of you who have been following this series and a warm welcome to our new participants. We hope that you find today's topic as fascinating as we do. We also hope that you will tell us biochar questions that you're grappling with, both so that we can answer them here today if that's relevant or in future webinars. Before I get us started, I want to acknowledge our partners, US Biochar Initiative and USDA's Agricultural Research Service, who are working with us on this webinar series and on the project that funds it. I also want to acknowledge our funding from USDA NRCS that is making this work possible. With that, I also further want to acknowledge for a moment that there are many uncertainties and challenges many of us are experiencing with federal funding right now. While this is important and my colleagues at AFT are engaged with our liaisons in government to try to resolve these uncertainties, I want to note that we will not be discussing or answering questions about this topic today. We will stay totally focused on the very exciting topic at hand of successes and barriers for biochar producers in infrastructure, in marketing, and in distribution to our agricultural producers. So next slide. A couple of brief logistics notes. We are recording this webinar today, and we will add that recording to our toolkit. We'll share that link. Live transcript is enabled for closed captioning. And so each of the biochar producers on the panel today will take a moment to introduce themselves and their facility. And then we have lots of time for question and answer and conversation. We've prepared questions to start the conversation, and we will then turn to audience questions in each of those three topical areas. We are going to be talking about production system type questions. We'll have conversation about successes and barriers. We'll talk quite a bit about engagement with farmers and ag service providers. And we will leave some time in each of those sections and at the end for audience questions. So when you have questions, please put them in the Q&A at any time throughout the session. Aisha is going to pull out the ones for each section, and then we'll get to any that we haven't gotten to in the end. I want to call out our evaluation survey. You see the QR code here. We very much hope that you will take a minute to fill this out at the end. We really take your input seriously. So if you have questions for improvement or topics and questions that we should address in future webinars, please do let us know. We really mean that. Next slide. I want to take a moment to introduce American Farmland Trust. We are a nationally connected nonprofit organization that takes a holistic approach to agriculture. We work at the interface of the land, the farmers and ranchers who manage that land, and agricultural practices and systems of practices that those farmers use on that land. Since our founding in 1980, AFT has helped land trusts and other farmland protection programs permanently protect about 8 million acres of agricultural lands. We've also advanced soil health and other conservation practices on millions of additional acres and supported tens of thousands of farm families. We really do our work from kitchen tables all the way to the halls of Congress. We systematically combine our work on the ground, coalition building, policy work, research, and technical guidance development. So we're working across many partners and stakeholders, not just to bring about change for a better agriculture in small pockets, but really the broad goal is to catalyze a transition to a new conventional agriculture, a new normal that we can really truly all be proud of. One that is resilient, soil health promoting, diverse, economically viable, equitable, climate neutral, or better, and sustainable. So that's really ambitious. We're not going to do that on our own. That's why we really work across partners. It will take everybody. And so if that mission excites you, we always welcome more members, more participants in our programming, more partners. We really look forward to working with you. As we do that work, one of the things that we're really engaged in across those systems is how to integrate biochars as a core tool in the soil health management toolbox. And that's now ready to scale up and really truly be integrated. We have a number of large projects on the ground. We are launching to scale up biochar use on farms across the country and connecting producers like you are going to be talking with here today to users of that biochar. So this webinar series is a piece of that body of work. Next slide. I want to make sure you all know that we have a national biochar survey that is out right now, open for responses. It's the first ever of its kind. We are really excited to have it out. We would love your help spreading the word. We've gotten a lot of responses. We want more. We want all farmers who have any interest in biochar, and especially those who have already been using it, to share their insights and share their perspectives on biochar. So please get this launched out. Send it out through your networks, through social media. Please share the message. Next slide. I'm here today. I want to acknowledge Aisha Tap-Ross, our co-host. She has led all the behind scenes work to organize this webinar. She managed to deal with the technical difficulties that we just had. So really glad to have her here. You can find the full practical biochar implementation webinar series on AFT's Farmland Information Center, which is our virtual library that we host. We will post this one there when that's recorded and ready, and we have more webinars coming, so definitely look out for those. We also have with us today Kiros Hagbu, who is AFT's new Senior Soil Health and Biochar Scientist, as well as Miles Gray from US Biochar Initiative and Kristen Tripp and Rachel Bashiri from USDA ARS. We're really glad to all be working together. And with that, next slide, I'm going to pass to Kristen Tripp, microbiologist at USDA ARS. She serves as PI on the National Biochar Atlas project that's funding the series, and she will then pass off to Miles Gray, Executive Director, to briefly introduce USBI. And then I will introduce our speakers and get this conversation on our way. So go ahead, Kristen.
Thanks, Bianca. And thank you all for coming on I think it's a Thursday morning, maybe in 2035, it feels like, but we're all here together, and I appreciate y'all coming and holding through the technical difficulties. My name's Kristen Tripp. I'm a research microbiologist with the USDA Agricultural Research Service. I'm based in Corvallis, Oregon. And one of the main projects that my research group is interested in is the development of decision support tools for the application and use of biochar in agricultural systems. That website is available at pnwbiochar.org, and it'll allow you to choose a biochar that can help address resource concerns for your crop and for your soil. Right now, that tool is only available in the Pacific Northwest. However, we're working with a great group of partners with funding available from the NRCS to expand the tool to the entire United States, including the US Biochar Initiative, American Farmland Trust, a whole cohort of scientists within the USDA, Oregon State University, and Washington State University. If you're interested in contributing biochar to our decision support tools, please contact me at the email shown below. And with that, I'll hand it off to Miles.
Great. Well, thank you, Kristen and Bianca. Just a quick introduction around USBI before this conversation gets started. So USBI is a 501c3 nonprofit. We're focused on increasing production and use of biochar in North America. And the primary way we do that is by helping to develop markets for physical biochar in agricultural systems, in the environmental space, in industrial applications, and also in the built environment sector. And a big part of that clearly is using biochar as a soil amendment. And this webinar is really important towards kind of building out that market for biochar as a soil amendment. We also lead on some standards work to standardize the production and use of biochar, which is really important as this industry grows. You know, being able to make sure that the product you get is reflected in a product sheet is extremely important. And then finally, I'll just note that we host an annual conference every year. It's one of the biggest biochar conferences in the world. The 2025 event will be in Minneapolis, Minnesota in mid-September, the 15th to the 18th. So if you're interested, you can sign up at biocharconference.com to get updates. Abstracts are currently being accepted for that event, and registrations will open in the next month or so. So we'd love to see you there. There's a lot of great biochar content, and it's always a great time. So thank you.
Thank you, Miles. Thank you, Kristen. I want to introduce our speakers today, who you're all here to see. We've got 4 phenomenal biochar producers, all working at different scales and different ways with different backgrounds. So I'm going to briefly introduce each of them, and then I will let them talk. So first off, we have Bill Hilgendorf with us. He's Director of Biochar and Sustainability at White Feather Farm and New York Carbon. He is a trained industrial designer. He developed an interest in discarded materials from an early age, exploring ways to repair and modify them for new purposes. His career has centered on upcycling and revealing the story behind materials in the design process. He found a compelling solution to the climate crisis when he discovered biochar. It transforms waste into stable carbon through pyrolysis, offering a means to improve soil, absorb toxins, and decarbonize environments. And so according to Bill, biochar represents the ultimate upcycled material. We also have with us Trip Bates, co-founder of Soil Carbon Innovations. He spent 25 years in the energy industry with extensive commercial and management experience in transportation, power generation, gas compression, and oil field services. Before co-founding SCI, Trip was managing director of Galileo Technologies North America. There, he became involved in renewable gas and developed a passion for using waste to create value. Since 2021, Trip and SCI have raised investment for building their first biochar production facility in Indiana and have partnered with industry to locate and market quality biochar to use as a soil amendment. We also have with us Dr. Tracey Carillo, head of agricultural business development at Applied Carbon. He's an accomplished agronomist and agricultural expert. He brings extensive experience in crop science, sustainable agriculture practices, and commercialization of innovative technologies. Throughout his career, he has held leadership roles in entrepreneurial ventures, product research and development, agronomic consulting, scaling up pilot agricultural projects, and more. Finally, we have Mayo Ryan, CEO and co-founder of the Sitos Group, previously served as general manager of North State Hulling Cooperative, a nonprofit almond processing cooperative in California. He began his journey into the world of biochar and carbon removal there in 2017. And prior to that, Mayo held various management and leadership roles in olive, pistachio, wine grape, and cotton agribusiness. He has deep expertise in agriculture and regenerative ag practices and holds a BS in political science and MBA in agribusiness from Santa Clara University. He is also a California Ag Leadership graduate and is an accredited farm manager. So wow, we've got a lot of experience, really diverse, really interesting insights that we are about to get. So I want to turn the floor over to our producers. Each one of them have a few minutes to talk to us about how they got started in biochar and what their production setup looks like. And then we'll go on to other question and answer. So go ahead, Bill.
Oh, Bill, you're muted.
Thank you. Thank you. Yes. Thank you, Bianca. As Bianca mentioned, I'm Bill Hilgendorf, Director of Business Development and Product for New York Carbon. And we are located in the Hudson Valley, about 100 miles north of New York City, straight up the Hudson River, right at the foothills of the Catskill Mountains, which you can see behind me here. I got into biochar. I guess everyone has their different roots, but so for me, it was design and upcycling. I really loved the idea of being able to take all these various wastes and turn them into something valuable and sequester carbon at the same time. So that's really like sort of how I got there. The next slide. Yeah, so this is a shot of our setup. We have what's called an air curtain burner. It's a Tiger Cat carbonator. It uses an open top to load the machine, and then a very high-powered fan to not only reburn any volatiles or smoke that's coming off it, but to create an air barrier to keep from oxygen getting in. Our production capacity is about 2,000 tons of biochar annually. We can put in 15 tons of biomass per hour. This machine originally was designed as a material reduction machine, and then it was re-engineered and tweaked to make biochar. Yeah, next slide. So our feedstock is primarily Eastern white pine. The company is located adjacent to a lumber mill, and that is their primary material that they process. However, we also are the local green waste drop-off centers. So tree service companies and homeowners, if there's a tree that comes down in a storm or needs to be removed due to disease or end of life, they can bring it there and we can process it. Our machine processes at about 600 degrees Celsius, so about 1,000 to 1,200 degrees Fahrenheit, creating a biochar with 85 to 90% carbon content and H to C ratio of 0.20. Next. This is just a shot of inside the firebox, which I appreciate. You couldn't run the machine this way, but you get to see one of the real advantages of the carbonator is there's very minimal pre-processing that takes place. So basically you can put in almost any size material that will fit in it, and it will make biochar. It's also less sort of moisture content specific than a lot of other machinery. You can put in high moisture material as well, obviously, or maybe not. The drier the material, just like your wood stove, the better the process and the higher the yield. But it is great in the way that it can produce biochar out of any kind of feedstock that's large enough not to fall through the grates. Additionally, it is mobile. We don't use it that way very often, but it is designed so that it can be driven through a forest or over land to do biochar in place as well. Okay, the next slide is a short video, just sort of showing some scenes of our process, because there's nothing like a video. So as soon as the biochar falls through the grates, it gets immediately swept by a water quenching system. This is just one of sort of our post-processing facility parts. This is grading, but then we also do have a milling operation that is part of the customer needs. And that's it. Thank you.
Trip, looking forward to hearing from you. You might need to unmute. I
Sure,
don't see you
absolutely.
yet. There you are. All right, go ahead.
Good. All right. Bianca, can you hear me? Great. So my name's Trip Bates. I'm co-founder with Dustin Hancock, a company called Soil Carbon Innovations. And essentially, we began the company with a focus on using biochar and other carbon amendments to help restore soils in the United States, especially in the Midwest and other areas where soils have been heavily farmed and heavily treated with synthetic fertilizers for a long time now, since certainly since World War II and before that. And additionally, to use the waste to capture carbon. So that's the about us of Soil Carbon Innovations. Go to the next slide. So this is just a profile on me. We can not spend very much time, but it kind of helps explain my origin story. I spent 25 years in essentially the oil and gas and heavy duty transportation business, power generation, and it was in some ways kind of born into those industries. About mid-career, I moved into an interesting space where I took my natural gas type experience and partnered with a company called Carillo Technologies out of Argentina, and who had a technology that could take waste gas, specifically from oil fields, where they were just flaring gas and take that waste gas and clean it and turn it into liquefied natural gas, and then reuse it. So that was kind of the beginning of my waste to value process, and that's where Dustin, my business partner, and I first met. Fast forward a few years, and we were working on a renewable natural gas project in Wisconsin, and we're shown what looked like peat moss, and essentially said, well, after this particular anaerobic digester that we were touring and talking to them about what they're going to do with their renewable natural gas, was a food waste digester. Once the food hit, it was a dairy waste, food waste digester. But once the food waste got through, it produces what to me looked like peat moss. We asked, well, what do you do with that peat moss? And they said, well, you can turn it into a fertilizer. But one of the guys that we were touring with pointed out you can also turn it into biochar. So that's where the biochar journey began. So in 2021, we partnered with some people and said, there's a lot of big dairy waste digesters, especially in the Midwest, that produce a ratable amount of waste that typically gets spread back over the fields in mostly liquid form. And we thought, let's figure out a way to dry it out and use it as a feedstock for biochar. So we've been doing that as Soil Carbon Innovations for coming up on 4 years now. And if you go to the next slide, I kind of explain where we are in the journey. Yeah, so this slide, so we knew there's a lot of things you have to do to become a biochar producer. You have to find feedstock. You have to find a technology that works, for your feedstock. And one of the other extremely critical things is you have to find offtake for the physical biochar. So in 2022, we assembled a group of people to be part of a NRCS Regional Conservation Partnership Program. And it was titled Using Biochar to Improve Soil Health and Conserve Nutrients in the Mississippi River Basin. We were awarded that contract. The lead in that partnership program is a company that had been around in the agricultural services for a long time, and we asked them to come along because we were a new startup company. And so we were awarded the contract. The purpose of the contract was to promote biochar for soils in the Mississippi River Basin at large scale. We believe that while smaller farms or medium-sized farms can produce biochar, it's something that's so valuable to soils as a soil amendment that it needs to be done at a larger scale in order to essentially enhance nutrient use efficiency, as it says down there. So to date, we have supplied and been part of the group that has applied and done soil testing, and we'll do at the end of the 5-year program, we'll do a hopefully fairly long and lengthy write-up about the benefits of biochar to the soils in the Mississippi River Basin. And we'll so far we've done about 15,000 cubic yards over 2,400 acres and 14 farms. So we're about halfway through this program, and hope that it really enlightens, especially farmers who don't like to read white papers. There's a lot of scientific papers out there talking about the beneficial use of biochar in soils, but it's very challenging to get a farmer to sit down, or even myself to sit down and read the 40 or 50 page paper. So we continue to work on actually the production of biochar. We would expect to be producing our own biochar up and running by this time next year. But in the meantime, we work with a strategic group of people to source biochar in order to supply for this program. So that's who Soil Carbon Innovations is. Look forward to answering any questions about it too.
Nice. Thank you. Yeah, so I'm Tracey Carillo. I'm with Applied Carbon. Applied Carbon is a pretty innovative, sophisticated technology. The equipment is fully mobile and modular. The company is based out of Houston. Just a little background about myself. I'm former research faculty from New Mexico State University, and I've worked in just about every cropping system there is in the U.S. and on a research side of it. And once I had an opportunity to leave academia, I went into industry and worked for several companies that included crop modeling, precision ag solutions, nanoliquid technology, and even forage crop seeds. So I have a pretty diverse background in the ag sector. When I started work with Applied Carbon, I was pretty excited that they had just some breakthroughs on some technology they've developed on making a fully mobile system. The company fully understands that transportation cost is kind of a bottleneck in getting feedstock to a facility or to a piece of equipment to make biochar and then transporting that back out into the field. And with the Applied Carbon technology, we can run infield, edge of field, or in a stationary setting. So it being fully mobile and modular, we can scale it up, add units as the feedstock increases. And as the season comes to an end, we can relocate that equipment and position it at other sources of feedstock. And that could include infield corn stalks, wheat and rice straw. We've tried wood mulch, sugarcane bagasse, which has a really significant amount of biomass that they have to deal with. And also, with the environmental issues like burning field residue and trying to find a mechanism to get rid of that field residue, we're offering a solution to that. So now they can mitigate the smoke and hazards and liability with burning in the fields and do it in a more controlled, sustainable manner that provides benefits to their soil health. Next slide. So this is a picture. This is our electric version. We also have a hydraulic version. Right now, we're constantly pushing the envelope on testing the equipment. We're running the equipment 24/7 to find out where all the kinks and wear and tear on the machine is going to be. And they've made some really nice advances on increasing the throughput. Depending on the feedstock, we're roughly about 2,000 pounds an hour right now. The machine is fully contained and can be pulled by a tractor operated off a generator plugged into 3-phase power. So it has a lot of ability to adapt to different scenarios, whether if it's an isolated location or if it's at a commercial mill or processing facility. Next slide. Yeah, so this is kind of our infield operation. And right here, what we're doing is calibrating the machine. So it has a harvester up front and it takes in the field residue, finally chop up and sends it over to the pyrolysis unit. And it goes through its drying chamber and then through the pyrolysis chamber and then finally through a quench, which will also include a inoculant, so we can paralyze, inoculate, and it'll have a spreader attachment. So it'll spread, and we can also pull a small disc or something behind it. So it does the entire process all infield in one pass. The other option to this would be to do edge of field, where they bale these corn stalks and we mulch them back up, run them through the machine, take the biochar and spread it back on the field. So that's another way we can run infield debris or biomass. Next slide. So this kind of demonstrates the modular setup. We have 3 machines running here. The feedstock we have here is pecan shells. So as long as we keep the feedstock moving through the machines, they're operating 24/7 and outputting a biochar from there. So based on the quantities or the amounts of feedstock that are available at a processor, we can stage just 1 to 2 to 3, 4 machines, however many we need to accommodate the amount of feedstock that's coming out of the processor. Next slide. Yeah, this kind of just shows you a little bit about the magnitude of biochar that we can create, in a stationary setting, operating 24/7. The machines have sensors on them that we can remotely diagnose and monitor. So our technicians based in Houston can monitor a machine if it's operating anywhere in the US and look for anomalies or pain points that we would need to address and keep them functioning, operating at capacity. So yeah, that's applied carbon in a nutshell.
Thank you so much, Tracy. Really appreciate that. Mayo, your turn, and then we'll get to all sorts of questions.
Well, thanks, Bianca. We're really happy to be here. And Tracy, it's an amazing presentation. That technology looks wonderful. We're happy to be a part of this, and I'm delighted to see so many people online. I think we've got over 60 people watching this seminar, so it's great. My teammate Jessica Brown and I look at the biochar business as truly as an and either, not as an either or, but an also and proposition. We really need everybody that's interested in biochar to produce biochar. The more companies, the better. So if there's anything we can do to help folks along the way, we're delighted to try. So next slide. We are a relatively young startup. My co-founder and I, Steve McIntyre, who has perfected the use of biochar in wine grape vineyards. He and I formed Sitos. Sitos, another name for Demeter, the goddess of agriculture and the protector of food and grain. Hopefully the goddess of carbon removal now. We formed Sitos in 2022, early 2022. Monterey Pacific, our sister company, farms about 20,000 acres of wine grapes in the Central Coast and had perfected the use of biochar in those wine grapes for about the last 10 years. I started my journey in biochar trying to create a bioenergy component for an almond hull or sheller, and read the book Burn by Kathleen Draper and Albert Bates in 2018, and that kind of started my journey along. If anybody hasn't read that book, it's a great intro to biochar. We picked a slow pyrolysis process to make biochar because our priority as farmers is soil health and plant nutrition. Right behind it is the ability to remove carbon from the atmosphere with soil carbon sequestration. But the machine we have is a design that was produced by professors Johannes Lehmann at Cornell, who's still there and active, and Stephen Joseph, who retired from the University of New South Wales in Sydney. They published an open source design in 2017. This is a much improved version of that. We have at Regen Monterey. We've been operating a pilot plant at Regen Monterey, this machine, for 20 months now to understand exactly how to use this machine, how it works, how to improve upon it. We're using municipal wood waste and hazardous forest waste as feedstock at Regen Monterey. And so have learned a number of really important lessons. The other side of this was a policy change. We were able to use this machine and its emissions to help get the EPA to rule that pyrolysis is not incineration and not combustion. Policy is a big issue in our industry now, and to have policy and governmental agencies to catch up with some of the work that we're all doing in building the biochar industry. Next slide. This is the newest version of our machine. We're going to be placing 3 of these side by side. That's our mechanical engineer, Mr. Hu. He's 6'4", so you can get a sense of how tall that machine is. But 3 of those machines will process about 26,000 tons of feedstock per year, making 8,000 tons of biochar and about 19,200 tons of carbon dioxide removal. On the left is a 3-pass dryer, so we'll be able to take very wet biosolids, grape must, olive pomace would be the wettest of the feedstocks that we would use to dry them down to 5%. But again, the plan at Treehouse Almonds, which we hope to have up and running the first part of 2026, our first commercial plant in partnership with Treehouse California Almonds in the southern San Joaquin Valley, will be 3 of those machines side by side. Next slide. Oh, this is the latest picture. We just got these last week. So they're just starting the insulation work. The picture on the right is the inside of the machine. The feedstock travels through that bottom trough that is lined with molded ceramic insulation. So it's a very limited, oxygen limited or oxygen free environment. We have a slight upward vacuum, positive 1 pound of pressure. So no air goes down into the feedstock trough. That machine runs at about 750, 800 degrees C. And at that temperature, all of the volatile organic compounds in the feedstocks that we use, whether they're almond shell, pistachio shell, municipal wood waste, are volatilized off and combust above the feedstock trough. And then that process, once we reach temperature, which takes about 2 hours, the system feeds itself, generates more energy than it requires to operate. So other than a minimal amount of electricity to run fans, motors, in the computer operating system, it doesn't require much energy at all. Next slide. This is the layout of the 3 machine system. So we hope to templatize this. The first one, as I said, will be at Treehouse California Almonds at their huller sheller. So we'll be utilizing their almond hull and shell, which is essentially a valueless agricultural byproduct. We generate about 1 million tons of almond shell in California per year. There really aren't a lot of uses, but it makes a wonderful biochar feedstock. Next slide. One of the innovations that we've had to come up on our own is how to get biochar into the ground. So on the right was the Monterey Pacific's first invention. This is invented by a fellow named Jeff Lehar, who runs the fabrication department at Monterey Pacific. The unit on the right will deposit 2 tons of biochar with 3 tons of compost, a 5-ton blend in an existing vineyard. Jeff's produced a machine that's much wider for almonds and pistachios. On the left is the applicator. We call it an injector for pre-plant, a pre-plant setting. And so we generate or develop about 1,000 acres of wine grapes a year using this machine. Monterey Pacific's clients all insist upon the biochar methodology that Steve and Monterey Pacific have developed over the last 10 years. And so that machine will deposit 10 tons of biochar with 15 tons of compost, so a 25-ton total blend. I saw a chat in the room, or a question in the chat room from Neil. What's the upside? We've applied 77 tons of biochar to a wine grape vineyard, and those grapes just took off. So we have not seen a real upper limit on what's possible there. I think the more the merrier, but it's 10 tons of pure biochar with a 15-ton compost blend is what we're doing. Next slide. Keep going. I think we've seen this one already. Keep going. A few more. Thanks, Bianca. There we go. So this is the applicator. Oh, that's the applicator in action. And so we've got 2 sets of tractors that are run on GPS. A ripper is going in and creating about a 4-foot trench, a delve. And that unit is establishing the GPS coordinates. The machine that you see here, the tractor that's there, and the tractor next door are all using those same coordinates. The drivers aren't touching the steering wheels. And then the wine grapes are going right over the top of that and planted in a very pure biochar compost blend there. In the almond world, we think this is very interesting. It might prevent almond dieback disease. So where an almond orchard is planted right behind another 25-year-old almond orchard. So some really interesting implications there. And I think that's it. Happy to
Wow.
answer any questions you may have.
That is all so fascinating. It is really amazing how each of you have a system or some things that you're targeting in Trip's case that are really needed out there and totally different from each other. So we're going to try to dig into that in the time that we have. So I want to spend a little bit of time, maybe the next 10 minutes, but not more, on your production systems. I would love for each of you to briefly let us know what's one particular thing that makes your system a particularly good match for you, or your approach in Trip's case. You don't have a system that's up and running yet. And if you want to comment on if you've thought about making use of the energy from your system, are you currently doing that? That's a big value, that all these systems are producing massive amounts of heat. Is that an option? Is that a difficulty? Would just love to hear a little more about your system. So this time we'll start with Tracey.
Yeah, so going to the energy side of it, we are investigating. We've got some just amazing engineers working for the company. Some of them are former SpaceX and NASA engineers, and so they've got some really nice insight into developing mechanisms or technology that we're going to adapt to the equipment, especially in a stationary setting, like at a mill or a processor, where we can run that heat back. One of the ideas we have too is we're working with several cotton gins, and the cotton gins generally use a lot of airflow, like warm air, to dry the fiber and move material around. So this could add, an added benefit to reduce their energy cost on that, and provide a just a carrot for them to have less, expenses on energy, but in the same time, creating biochar. What really excites me about the equipment is the mobility of it, in the modular setup, how we can adapt. So I'm, working with different cropping systems. They plant corn in July in South Texas, and then they might plant corn in, much later in the season. I'm sorry, they'll be harvesting in July in South Texas. So the season changes just in Texas as you move from south to north, and the machines can adapt to that mobility of the season and go where they need to go, and not just be stuck in one place. And then again, help with reduce transportation costs.
Yeah, that's some really cool stuff you're exploring there. I'm wondering if any of the rest of you have thought about this issue of how can I get the value from the energy from the system. I know, Bill, you've said you've had that, Mayo, so maybe we'll just get the two of you and then we'll move on to the next topic. It's questions flowing in, so go ahead, Bill. Oh, you're on mute.
Yeah, sorry. That's something we talk about all the time. I mean, the machine was purchased before I came on board, and it was really a solution. It was looking to solve two problems. One is we had a farm, started in the 1750s, that had poor soil. We had a mill next door that was trying to figure out a better solution than just making mulch out of their waste and offcuts, and that combined to create New carbon, and the carbonator was the right fit for that. But yeah, I mean, I'm always thinking about the energy and our current inability to capture or valorize that heat. Although we've definitely gone through some ideas of putting a hood over it, or encapsulating it inside of a building, and taking some of that heat either to run the kilns for drying the lumber, or also running a thermally modified wood process. So it's definitely something always on my mind.
That's really cool. How about you, Mayo?
Yeah, we've been looking at the heat. So the two things that come out of these machines are a lot of heat and biochar. That's it. They're almost emissions free, or virtually emissions free. So we are taking the heat and running it through an organic Rankine cycle electricity generator, which are notoriously inefficient. The maximum is probably 20 to 22% efficiency. So we'll be getting about 5 megawatts of total power or heat Out of those machines, at 20%, we can generate 1 megawatt of renewable 24/7 non-combustion energy, which we'll either give to the host, so an almond Holler Sheller through an interconnect agreement, which would be net metering, so we can offset the energy that an almond Holler Sheller, another processor, uses, or put it into a challenged microgrid. And so that's the plan. No, absolutely. We've always tried to incorporate, use the heat. Another way would be to, put the heat into a boiler and create energy from a steam boiler. But organic Rankine cycle, it's an old technology, and not very efficient, but inexpensive and easily adapted.
Yeah, it's a tricky space, right? I mean, using that energy, it takes more engineering, it takes more really putting some thought into how to do it, and then you need the equipment. But if we can do it, it just seems like such a value add for this industry. I'm going to move on to some other topics. We have gotten some questions from the audience about whether, as you're producing it, you are inoculating your biochar prior to application, and whether there's consensus about the best inoculant or the best blending mechanisms at that production stage. So Trip, I know you've got an RCPP. Just briefly, are you all thinking about that as you're putting all that biochar out there?
Yeah, yes, absolutely. We for every ton of biochar that we put out, we would like to see a ton of compost. Sometimes it's not practical to use compost, and you have to use raw manure. But what we want to avoid is applying biochar to a bean field or a cornfield and seeing the nutrients actually being kind of sucked up into the biochar the first season and having a negative effect. So the standard operating procedure is absolutely to use compost or raw manure of some sort and mix it up.
Great, thank you, Trip. Just raise a hand. Are other folks inoculating the biochar? Tracey, you guys are? Yeah. There's another question in the chat. From your perspective, do you have anything to share about using invasive species as a feedstock? I'm curious whether any of you have done that. Mayo.
We have not at Sitos, but in the northern part of the state at North State Holding, the Stony Creek, which is in Glenn County, runs through Glenn County, has Arundo-Donax, which is a quite harmful invasive species. And with the local RCD there, we looked deeply at removing that Arundo-Donax. It'd provide a very fine feedstock ground. So there are lots of wins in the biochar world where there are co-benefits that just seem to be endless co-benefits, and that would be one, to be able to use invasive species feedstock. Absolutely doable.
Absolutely. Yeah. And Tracey, I'm thinking of your machinery that you just showed us. I'm really curious. Obviously, that would work in an agricultural field, but can you take it through the woods? Does it do that? Would you need to redesign it?
You can. We're looking at tree plantations and also invasive species cedar. Like Oklahoma has about 17 million acres of invasive cedar that NRCS at the time were paying to have those removed. So they're just sitting out there drying up, and they could provide a source of biochar to go back on the land.
Yeah, I hear about this from producers all the time. We've got some farmers we're talking to who are saying, I've got lots of honeysuckle on my land. Can I deal with that? I've got rose bushes that are just taking up the space, ripping up my pants, right? Mm-hmm. And there's possibility to make biochar if you have the right equipment. Now, at what scale that's possible, there's more to dive into. I'm going to pass us on to the next area, barriers and successes. Want to spend a little bit of time here. I'm wondering if each of you can briefly talk about 2 key successes that you've had that you haven't discussed yet. And then if there's any lessons learned or any key barriers that you're still grappling with. So we'll start with Mayo this time.
Key successes. I think some of the policy work that we're doing to help the biochar industry move forward is really important. EPA changed their spots quite a bit. Thankfully, in September, they released a national set of guidelines, which said that pyrolysis is not combustion, not incineration, and therefore not subject to the Clean Air Act. We had to undergo quite a rigid set of tests early in 2024, which were quite expensive. Those are no longer necessary for folks in our world. So that was a big win. I do think the policy wins are important, to get DOE, USDA, Forest Service, which is great. Forest Service is actually a big biochar fan. And Treasury on the 45Q, we're trying to get 45Q to be tech neutral, and so there'll be some interesting tax benefits. So policy successes are important. We don't think about that a lot. On our side, we're really delighted with the improvements we've made to the machine. Our manufacturers and the custom manufacturer, since we've been operating our machine at Regen Monterey, we've increased the capacity of it by 300% in partnership with our manufacturer. So that's a good thing. There, in our world, that's a difficulty. There are probably a half a dozen really good manufacturers of slow pyrolysis equipment. None have the capacity to scale the industry the way we need it to scale. So we're hoping that it's not just our businesses that can scale and grow and start up for the folks that are on the line today, but the manufacturers of the equipment likewise need to scale so that we can move our businesses forward.
That's really exciting stuff. Trip?
Yeah, I would say a key success that we can point to is actually being out in the real world and applying the biochar to the soils at scale. And I think it's a really important thing. And it's not just the biochar. I think that biochar, I've said this before, I think biochar and compost are a little bit like peanut butter and jelly. They go together very well. And so being able to do that at scale has been a huge success. I'd say that the challenges that remain are the economics. They're always going to be there for a biochar producer to raise investment in order to be able to produce at scale. I think that one of the successes is the continued growth of the carbon dioxide removal market that helps the financial side of things. But you have to be very efficient at how you do it. So there's challenges every day, and there's successes every day, and you just need to balance them and keep on going.
Yeah, absolutely. And that economic question, I will actually come back to that when we talk more about how to engage farmers. There are a lot of questions out there about that, so I will be asking more of those. Bill.
Yeah, I think for us, we're I think the only sort of biochar producer at our scale in our region, the sort of Eastern New York, Western Massachusetts, Western Connecticut sort of region. And so I think it's just been amazing, the growth in the market that I've seen over the last year in particular, but the last couple of years. I mean, when we started out, we were only running the machine once or twice a month because the demand just wasn't there. And through some of my other work on the research, development, and education side with White Feather Farm, I've been able to reach so many different people, and just seeing that interest grow. And then along with it, the ability for us to produce more, to sell more, has been really exciting.
Yeah, it's really exciting to see that connection happen. And I know we've kind of connected you in with some of our trials, and AFT is in that space of connecting producers and the farmers who are out there who could benefit from biochar. So
I think one last thing just on that is to be able to be a local source for people to bring their waste to, and to have it go into an upcycled product or a stable carbon like biochar, versus the alternative was a lot of these companies are just finding an edge and pushing the material over and letting it just sort of rot. So I think that feels positive every day to be able to offer that resource to the community.
that's fantastic. A couple of key highlights from you, Tracey.
Yeah, so I got a second Mayo and Trip, the policy and increasing the throughput technology, and we've made some really significant advances in our technology within the last 6 months. I've been working with them for since March, and from when I started to where we're at now, it's just been light years ahead. So I really look forward to the next year, what that's going to look like. And we do have a NRCS funded grant that we're looking at, using running the infield version and looking at, because NRCS is concerned about removing biomass from the field and depleting organic matter. So we have a study going on in Texas for that, and we'll be sharing that information as the data comes in.
That's really exciting. I would love to hear about that when you all come up with those data. All right, I want to talk a bit about engagement of farmers. A number of you have already a bit spoken to that. There's a lot of successes you all are having. I'm curious to hear what challenges you would say are the biggest in terms of getting farmers to take this up, and whether you're doing anything on the economics front. How are you talking to farmers about the economics? How are you talking to them about the most important questions? And are you doing anything to make it more affordable through your company? So let's see, this time we'll start with Trip.
Yeah, it's the physical sale of the biochar is extremely important, and is the one form of revenue. The sale of the carbon dioxide removal credits is the other, which in some ways is easier, as crazy as that sounds. The farmers, it depends on the type of farmer. Are they a regenerative ag type farmer, or are they a sixth generation row crop farmer who really only cares about yield? And so there's not a single answer about how you approach the farmers on the physical sale of the biochar. There's obviously programs such as what we as Soil Carbon Innovations are involved in that subsidize the cost, to the farmer. A lot of farmers don't want to take part in the program, so it's a constant battle. And I think that had a conversation with Miles Gray just last week about this. Sometimes in the beginning, maybe it's better to focus on the farmers that have additional dollars to spend, that make more dollars per acre than a traditional than the others. I'll just say that. And so it's an everyday conversation and everyday thing that we think about on how to monetize the actual physical biochar.
Great. Tracey, what are your thoughts on this?
Yeah, so it is a challenge. Like Trip was talking about, regenerative type ags. You got the conservative ags, and then you got, some just hardcore, I'm going to do it the way my father always did it, his granddad did it, and so forth. But what I found is, like Trip mentioned, targeting regenerative, more progressive, innovative farmers, and working through co-ops where you can target, let's say the co-op, they can identify 3, 4, or 5 of their most progressive farmers, start working with those individual farmers and set out some trials. It's usually, what I found, is a 3-year process. A trial phase where they do side-by-side observational, they collect yield data and so forth. Second year, they'll adopt a little more acreage, and hopefully by the third year, it's farm scale wide. And so it takes some time and relationship building to accomplish that.
That's such an important point, right? That time, that relationship building. A farmer, that's their viability, right? That's the way they feed their family. That's the way that they make their business. It's got to make sense to them, and different people have different motivations, right? And so really making sure to approach people to find out what matters to them, right? And what questions they do have, so that we can meet them where they're at and then help them adopt at whatever level it may work for their farm, or they might need to see somebody else adopting it successfully first. Mayo, what are your thoughts on this?
Yeah, I mean, grower education is critical. We're not going to have carbon sequestration or atmospheric carbon removal without getting biochar in the ground. I think it was over 90% of all carbon dioxide removal delivered last year was biochar based. So while all the methodologies and technologies are great, biochar is the most shovel ready and the most efficient. So it all boils down to growers. It really begins and ends with agriculture at the moment. So in wine grapes at Monterey Pacific, we've proven the value of biochar. The vineyard that's behind me in my background was planted with biochar last summer, and it's just taking off. We've established this in wine grapes as a standard production practice, and what we're hoping to do is take that knowledge and move it into horticulture: almonds, pistachios, apples, hazelnuts, walnuts, and we're We've got a pretty big trial coming up with Arataberry ranches in Fresno County. In September, we'll plant 150 acres of a 300-acre almond planting with using our vineyard-based biochar methodology, same equipment, same 10-ton biochar, 15-ton compost blend. But it's going to be a long road to hoe. We've got to educate growers. We need to establish standards, and I think USBC and USBI are both doing that now. And so look for good things coming in 26 about biochar standards. In wine grapes, we've established the proper rates and methodologies for application. And the economics are the tough part to get a grower to understand the return on investment. Thankfully, NRCS has code 336, practice code 336, which is a soil carbon amendment program. They're going to help growers use biochar and pay growers to do that. I think the number is $845 a ton. It's still new. I mean, we're still all trying to build these programs together, but they're out there. Grower education is critical. We don't get this done without getting biochar in the ground.
Absolutely. And the economic data, right? I mean, if you've got it figured out in wine grapes, that's fantastic because that's a big value crop, right? Can we get it figured out in corn and soy and vegetables of various sorts, right? In different climates, different soil types. Right.
No downside in wine grapes. It's a positive ROI after just a couple years. Yields are up substantially. Water use is the same. And in our case, wine grape quality is the same. Usually it's higher yield, lower wine quality. That's not the same. We see only benefit. There are no downsides.
That is really fantastic. Bill, what about you? You all are pretty new getting it out, out on farms. I'm curious.
Totally. I mean, I want to just follow up on what Mayo was saying around farmer education. I try, you know, these webinars, online resources are amazing, but like to be able to get out and get in front of someone in person and talk through, you know, some of their questions, their concerns, you know, how to apply it and stuff. So I try to get out in the field, you know, as much as I can to be on farms, like, you know, looking at specifics. That's really important, you know, like the education component. Also, you know, Cornell is an amazing resource for us in New York. I worked a lot with, actually, just last week I lent Cornell Agritech. They have a lab down the road from us in Highland, and I lent them my personal Ring of Fire kiln so they could do some testing on orchard prunings in the orchard that they have behind them, though, to also help like collect data to give to their growers, the association that funds them. So, yeah.
That's so great to hear. And all these collaborations are so critical as we figure out the space. I haven't heard a lot about sort of the really specific, like what's that one barrier that you're really grappling with that you haven't been able to figure out? And particularly, I want to hear from you if you know of anything that AFT, USBI, ARS, NRCS should be doing that you would like to see happen better for improved collaboration, for really moving the space forward. What would you say we most all need to work on? So start with Bill this time.
Yeah, you know, I think it's come up a few times, but the economics are certainly a big challenge right now. I mean, with any new industry, you know, you're constantly trying to grow the supply and the demand side at the same time. But you know, this comes from my furniture background, actually. You know, with a love of reclaimed materials and upcycled materials. A lot of times people think, oh, you're getting your material for free or cheap, or even getting paid, you know, an offtake or not an offtake, a tipping fee. It should be cheap, you know, and it should be. Yes, we need to make biochar low cost and available for farmers, but you know, for someone like us in our scale and position, you know, we're not big enough yet to we're sort of for it to make sense for us to get our system, our project set up for carbon credits to go through that process. So that's off the table. And then, you know, production, it's expensive. And for us, it's still a lot of manual labor to run the machine. It's not automated. So, you know, every ton we produce of biochar is 10 tons or 15 tons of feedstock, you know, so just the logistics of moving that around, loading and everything costs money. And then post-processing, you know, no one wants to pay for another process, you know, on top of that. So I think, you know, figuring out how to support and give value to really show the real value of what biochar could be, not only in soil, but in other applications as well, and yet also make it very available to reduce those barriers to farmers to get in the soil, which is, like Mayo said, the ultimate goal here.
Thank you so much. Those are all really important points. Tracey, wondering if you've got any recommendations for us or key barriers that you're facing.
Yeah, so I mean, it all boils down to ROI for the farmer. So for us to get some, a product to the farmer that's have at least a 3-to-1 return on investment, we're going to have to, like Bill said, the economics. We're going to have equipment that has a really high throughput. The conversion of the feedstock is also important. Corn stalks versus a harder wood, where you can generate more biochar with less feedstock and having a source of that amount of feedstock. So there's a lot of components involved in ROI. We just got to work a little bit better and make more advances.
Absolutely. I seem to keep hearing that one, right? The ROI. What's the return on investment? If I buy this biochar for this very expensive amount, what's it going to get me, right? And that's certainly the number one question that I hear from farmers, and we are working in that space as well. Trip?
Yeah, I mean, I'm just going to echo, I think, what Bill and Tracey have said. It is ROI. The farmers, whether they're more progressive and regenerative, or they're more row crop and want to do it the same way that their great grandparents did, it's a razor thin margin business, and so it's really important. But I'd add to it, we've been doing this. We're not biochar. We've only been doing it for 4 or 5 years, but we have moved biochar from point A to point B in long distances. And one of the things that I see as a big challenge in the industry is, we consider about a 300-mile bubble to be where the economics begin to break down for both the biochar producer and the farmer. So I think that one of the things that's going to need to be done is there's going to be a lot of room for biochar production in about a 300-mile bubble across the places where biochar is useful. So there's a lot of room for that. Tracey's group in Applied Carbon has taken a different approach and produces it in the field, but as I've learned today, also does more of a stationary biochar approach too. So I think it's a mixture of those things to really tackle the transportation. You can get about 60 cubic yards in a typical trailer. If you're doing 4 to 6 cubic yards, depending on the weight per acre, and you start doing the math, you're burning a lot of diesel fuel in order to get the product where it needs to be. So it's that's one of the bigger challenges. I just think we're going to need, as an industry, to have more areas where producers can access biochar.
Yeah, absolutely. So we tackled the economics, and it seems like all three of you thought economics are a big barrier. I know, Mayo, you've said for you not as much because you're starting to prove it out, so that's great. The distances are definitely an issue. Mayo, I heard you say earlier that you thought more people were needed in the biochar production industry. I wonder whether that's partly because we have such great distances, or whether you want to maybe talk a little bit more about what the needs are there. Why would you want a whole lot of biochar producers to come in? What's it like collaborating across this industry? Is there competition? How does collaboration work? Tell me a little bit about that, and then any other key gaps that you were thinking of that are not the thing I'm asking you about right now.
Well, I mean, at the very, very highest level, when we start to think about, removing gigatons of atmospheric carbon, it really doesn't happen without biochar as the most efficient and shovel-ready means of doing that. And so all of us need to participate. We need, it's hard for me to get my mind around how many biochar companies need to be formed and get up to speed and scale in order to meet that demand. I mean, we talk about a 2030 demand, a 2045 demand. just to meet the Paris number, which I don't think we're there. We're at 2 degrees or above. And so we have a massive need for atmospheric carbon removal, and biochar is just one of the better technologies, or a good technology anyway, of getting that done. In California, by law, we have to be carbon neutral by 2045. Again, if biochar is a big part of how we get that done, we need all the biochar companies we can think about need to get formed and scale up in California to meet that demand. So that's a good thing. That's an incentive for us to build these businesses. I think growers are true environmentalists. I mean, they're working with a non-renewable resource, their soil. And biochar is a way to reverse desertification and soil degradation. We're seeing it in wine grapes, a really big increase in productivity and plant nutrition with biochar. We really need to shift the focus into a more regenerative ag way to do it, and biochar facilitates that. What we're trying to work on at Sitos is a way to get growers a stack of carbon offset or inset credits to help mitigate the cost of biochar. Unfortunately, today, because the LCA life cycle assessment has to stay with the biochar producer, it's tough to get a grower carbon removal credits. I'd love to see carbon indexing at agricultural processing sites. It's something that ethanol industry is doing in corn in the Midwest, but boy, why can't we do it at an almond processing company or pistachio or other processors here out on the West Coast, so that a grower that is adopting or adapting to better climate production practices like regenerative ag might get paid for it. Might be an interesting stack of different offset credits, but nevertheless, it's dollars to the bottom line. And I think carbon is a really interesting hidden line item on every grower's income statement. And their ability to farm carbon is a hidden item on their balance sheet as an asset.
Right, absolutely, because it really influences soil health. Even aside from sequestering carbon for the global good, we have so much resilience that we build when we get plenty of carbon. We improve aggregate stability, we improve infiltration, so we deal better with extreme rainfall, we deal better with drought. So biochar is a really big asset there. Thank you for sharing all that. So we are about 12 minutes from when we were going to close out. I'm going to look through additional questions from the chat and pick out a few. Aisha, if there's key questions from above that I didn't get to, if you want to put them in the bottom section there, I will get to a few of those. And then I'll close out right on time, but then I think all the biochar producers may have a little bit of extra time and we can continue a little bit of Q&A after we get to 2:30 Eastern time. So one of the questions, or a number of questions around this, how are you finding buyers of biochar? Do you go out? Do you go to conferences? Do you go to farmers markets? Do you go by word of mouth? How is it that you get the word out there? How is it that you get people initially interested in buying your biochar? So maybe start with Trip there. You've been in the RCPP space a lot.
Yeah, we've our approach has been to partner with NRCS and Conservation Practice Center 336 and get the word out that way, in order to convince the farmer that this is something that's good for their soil, therefore good for their yields, and good for their the cost of the inputs, or the lower cost of input for nutrients. That's kind of we look at doing it at scale. There's other ways to do it though. I mean, I'll let the other speakers do it, but the approach we've taken is start out with government help, which in these days is a little bit wonky, but we see it a return to how it should be, and then from there having actual proof of the benefit of biochar to the fields.
Absolutely, because if we can really show that return on investment and a farmer becomes comfortable with that practice, then they can be off on their own doing the right thing for their farm. Bill, I know you've talked a little bit about this. Anything that you have to add on this one?
Yeah, I mean, I think it's all of the above. When you mentioned like conferences, farmers markets, field days, like any opportunity I have to talk about biochar. I do. It's my kids make fun of me, but my license plate on my truck is just biochar. It's a vanity plate, and
That's
you wouldn't
fun.
believe how many people come up and ask me what's biochar. So I think there's a lot of creative ways to get out there and talk about it. I think, you know, from the education side too, we're working with nonprofit farms in our region who have their own base of you know, other local community farms, as well as doing their own education programs. So if I can teach them about biochar and do some on-farm biochar production with them, then it'll grow exponentially.
That's really great. Mayo, you've talked a bit about markets. You're getting stuff out on vineyards clearly. Any other key market areas, tips that you have for folks for how to sell your biochar?
Yeah, Tracy nailed it. You know, what we're attempting to do is find the most trusted and the respected growers in certain areas. You know, the guys at the coffee shop that the rest of the growers listen to, the early adopters. Monterey Pacific and Steve McIntyre were early adopters of biochar and wine grapes. And so we're trying to find those folks like Dan Roddenberry in Fresno County, who's agreed to not just do this large almond biochar trial in a new planting, but to actually be open to converting his existing fertility program to a biochar-based fertilizer. You know, a biochar-based fertilizer is a really interesting way for us to go. And if we can use our biochar in that as an ingredient, perhaps the carbon removal credits now can be, you know, shifted more to the grower side of things. So, you know, there are a lot of different things that we can do with growers. I think growers want to make that shift. I think growers are interested in pursuing some components, if not all, of regenerative ag. They just need to figure out how to pay for it. That's the rub right now. The irony, the paradox of this is that we can't give away biochar. We need an interesting price for biochar to scale our businesses. You know, carbon removal isn't enough to sustain a biochar company, at least at this time. I may be wrong about that, but in our world, we need both. And so we need a fair price for the biochar, which might be a little bit high on the grower side today. So I think over time, we're hoping we can find that balance.
Absolutely. And Tracy, you take your equipment right out into the field. So you're not just selling biochar, you're really selling a service, I think, right? So is that easier? Is that harder? What are your thoughts?
Yeah, all of the above. It's easier and harder. So that the process still is a little slow for farmers to wrap their mind around it, because you know, once they finish harvest, they're on to the next thing. So we still got some work to do on that. But yeah, I think, you know, like Mayo was saying too, like if we can identify the progressive growers, we do a lot of field trials where we'll provide some material they can do side by side, as long as they are signing up for the NRCS and 336 program. So that helps us to leverage that following year, where it'll be or at least subsidized to some level. And we also like to capture the, you know, the carbon credit component of it.
Yeah, absolutely. Well, one last quick round of questions here. Folks are wondering which crops and soils respond the best for biochars, and which how you sell your biochar, ton, yard, cubic foot. So if we can just do a quick all the way around the room just on those two. So Tracy.
Yeah, ton, yard, cubic foot, shovel, bucket. It's like everybody has a different measuring stick, you know, metric tons, and we prefer the just selling it by the ton, because we know it's going to have some moisture in it because we inoculate it, and it's going to have some drying time too. So it's easiest just for us to load, you know, inoculate it, load it in the truck, and sell it that way.
How about cropping systems?
Cropping systems, gosh, you know, I was going to mention, don't get stuck on one crop, because we've made applications on coastal Bermuda pasture fields that had some really nice results with it, and they'll aerate their soil, so you can make an application to go in and aerate, incorporates it some, and they've managed to overcome some of the drought situations we've had in Texas, and also sod farms are having really good success. So it's not just row crops and, you know, orchard crops. There's other
More
agricultural
opportunities.
situations. Yeah, definitely.
Yeah. Mayo.
Yeah, I mean, we're shooting for all the crops, right? And permanent plantings, our application methodology works really well with permanent plantings. So wine grapes, almonds, pistachios, walnuts in California, apples, hazelnuts in Oregon. We kind of need it all. In a row crop setting, it's a little bit more difficult, but a no-till drill is a great way to apply biochar. We do want to get it underground. With the latest inert night studies, sort of end of last year, we've proven that we don't need to go to depth. We don't need to go to really cold soils. That biochar underground will last a millennia. So we just need to get underground so that it's not eroded or blown away or flooded off. But just to get it underground somehow, some way. I'm going to hop off here at 11:30. I have another meeting, but I do want to give a plug to. For all the biochar folks in the room, we have two really wonderful national organizations, the U.S. Biochar Coalition and the U.S. Biochar Initiative. USBI and USBC are two great organizations, along with American Farmland Trust and others that promote biochar. Please don't hesitate to check out both organizations. Miles Gray at USBI is doing a great job with his team, and Maureen Walsh and her team at USBC are really doing great work. And so it's just really one big happy family. I just try to bring everybody together to promote the industry. It's a great place.
Thank you so much, Mayo. I really appreciate you taking the time. Trip, what are your thoughts on tons, cubic yards, etc.? What production systems are best? You're mostly just working in row crops. It is working.
Yeah, I mean, I'll have slight disagreement with Tracey. If we can have a standard across the board at cubic yards, a volumetric measurement of biochar, that would be a really happy day for us, because the moisture, it can really fluctuate. And when the moisture fluctuates, you start talking about tons. It just gets confusing to people. This could all be mathematically, figured out one way or another. But anyway, so cubic yards, if I had my vote, would be the way to go. As far as crops go, I've never put myself off as an agronomist or a soil health expert in any way. I found my biochar journey comes through the love of taking a waste and using it to do two good things. Let's make the soil healthy, and let's remove carbon from the atmosphere. But in conversation we had in Salt Lake City, where I live, the National Association of Conservation Districts came to town, and I'll say two things. It was a big conference. There was 500 people there. I didn't have to explain biochar to a single person, which I think is wonderful. I can explain biochar, kind of like Bill said. I don't have a vanity plate that says biochar, but I'm very skilled at explaining biochar. But to have an entire conference there that everybody knew what biochar was handy. But one of the things that we talked about with the people that are experts in producing was that sandy soils. Look for sandy
Absolutely.
soils. Don't go look for the richest, most beautiful soils, because yes, there will be benefits, but go find soils that need some help, and sandy soils are certainly one of them. So that's what I would say.
Thank you, Trip. Well, I want to thank everybody who anticipated being here right until 2:30. I want to say again, please do fill out our survey. We love hearing from you. We want to know how that went. Was that great? Did we miss something? Are there gaps? Do you have further questions that we could fit into the next series? I really want to thank our panelists for being here today. So much exciting information shared. Really glad you all joined us. We hope you look up all of our organizations, that you collaborate with us. If you have ideas, we would love to hear from you. So have a wonderful day, and we will stick around for a few minutes. Those of us who can, I know Mayo had to step off, but those of us who are able to stick around for a couple of minutes, I could address a couple more of the questions in the chat, and then we will close out. So thank you again, everybody, for joining us today. We are really excited that you made the time. Okay, so with that, we have all sorts of more questions in the chat. Apologies, we'll not get to all of them. But I'm going to look at what key questions we had. One person asked, is biochar the same as activated charcoal? So I'd love somebody to address that who has some background in that. Somebody is asking about whether any research has been done on soil microbial profiles post biochar production. So put those two out there. Who wants to answer the question about biochar and activated charcoal?
I mean, I'll take a stab at that one.
Go for it.
So biochar can be activated charcoal, but it needs to go through another post-processing sort of process to increase the surface area to its maximum potential. Different biochars have different absorbency qualities, but certain biochars can certainly be replacements for activated carbon that are fossil-based or otherwise.
Thank you, Bill.
I'd add just real quickly to that. It's all about the feedstock too. We have focused heavily on dairy manure digestate, which if we, at all the testing that we've done, if you get around 60 to 65% carbon out of dairy manure digestate, you've done well. I think with activated carbon, your feedstock is going to need to be more of a wood-based feedstock, so you can get that higher 85 or 90% carbon.
Research in microbial profiles post biochar production. I'm looking
Yeah.
at Aisha. She's smiling. I know she's done research in that space. Tracey, you've done some research in
Oh,
that
go
space?
ahead. Go ahead.
Oh, well, I mean, I'm not one of the biochar producers, but yes,
Yeah, but you're
research
co-hosting.
is being done. Yeah.
Go
Research
ahead.
is being done on soil microbial profiles post biochar production. It's actually one of the research plots that AFT is starting in the spring is looking at that, and there have been others as well. Tracey, do you want to?
Yeah, I was going to mention, that the porous texture of the biochar offers a really beautiful home site for microbes and beneficial organisms. So what we like to do too is inoculate, add a sugar or a molasses to our biochar to provide a food source. So the biochar serves as the condominium, and you provide food, and they're off and going. It's just a really nice complex for microbes.
How very interesting. I had not heard of of adding sugar yet. That's interesting. Have you guys done trials with that, Tracey?
We got some data coming in. Oh, here pretty soon. I can share that with everyone.
That'd be
It's actually
fantastic.
that's actually like really interesting. I also have not heard of that. So like one of the research that I've done is looking at what type of inoculum works best if you're looking at like soil or direct microbial inoculum, and we found that native inoculum works better, and so yeah, putting a sugar to increase those native microbes is really fascinating. I'd love to see that research.
Yeah, the product we use is from a company. It's a granular molasses. So it goes out at £1 per acre. It blends in with our other inoculants, and so it's pretty seamless. And we think too, it provides a coating to help contain the inoculant. Although we are finding that once you inoculate it, that biochar can hang on to those nutrients really tightly. So yeah.
If you
Yeah,
build
that's
it, they will
interesting.
come.
Sorry, go ahead, Bill.
No, I was just making a joke. If
you
you
build
build
it,
it,
they'll
it'll
come.
come, like the condominium for the.
Yeah.
Has
Absolutely.
anyone experimented with EM1 as a just sort of generic inoculant?
I have not.
I mean, I guess that what I'll say about, sorry, this is Kristen. I guess what I'll say about EM1 is that those microbes are not soil microbes, right? Those soil microbes are a lot of lactobacillus.
Yeah.
And so although they might do a good job at kind of decomposing the volatile matter that's on the biochar, I don't think they're going to provide a lot of function in the soil once it's actually in the soil. But certainly, like, if you talk to Kelpie Wilson, she's
Yeah.
a huge proponent of EM1.
Mhm.
But again, I think it's just kind of a way to process some of those foods into something that's more digestible for the microbes that are in the soil, to help recruit them once the biochar is there.
Yeah.
Totally should have thought to call on you, Kristen. I'm glad you chimed in.
It's okay. There's a lot of expertise in the room.
Yeah, there sure is. And there's so many things we could talk about. We could probably just talk about microbial profiles and microbial function in the soil based on biochar versus no biochar and what kind of biochar. I'm sure we could do that for 2 hours and keep coming up with new stuff. So there's a couple other interesting questions. There's a lot of other interesting questions. One of the thoughts I'm having here is we have an FAQ online, and maybe at some point we revisit that FAQ, pull in a lot of these excellent questions and answer them so that we've got an updated version online. One question that I saw here, are any biochar operations offering revenue sharing with farmers via carbon credits? And I know Mayo left, he might have had something to say about that one. Do any of the rest of you know about anybody doing that? Revenue sharing?
I can chime in.
Yeah,
I
please
can
do.
chime in a little bit about that because we get the question all the time. So the path to revenue for a biochar producer, as far as carbon removal credits go, is a producer credit that's paid directly to the producer, the biochar producer, not the farmer. That incoming revenue, and unless things change over the next 5, 10, 15 years, really is needed to lower the cost of the actual physical product of the biochar to the farmer. And it's really, it's an interesting topic. A lot of the farmers, I don't want to say don't get it. They say, well, why can't why can't we share in that revenue? And then you explain that, well, it's to bring the cost of the product just to a level that you can pay for it. And so it's always an interesting conversation. Now, could that change? Could the carbon dioxide removal markets, which is a private voluntary market, take off, one day and provide, instead of hundreds of dollars, per ton of carbon removed, provide thousands of dollars? Then I think the conversation would change. But as it is today, it'll make the physical product less.
Yeah, absolutely. I mean, I've heard of some production facilities that are, yeah, that absolutely makes sense. I've heard of some facilities that are getting the carbon removal credits and then offer the biochar for free to farmers who can come and pick it up. So that's been an interesting model. I don't know how many can swing that economically, but that's been an interesting thing I've heard about. There was another question in here. The question is there a limit to the amount of biochar that can be applied to an acre of soil, given that when you apply biochar, it lasts for a really long time in the soil? Any thoughts on that?
I mean, we've put a lot of biochar in soil, like a lot of biochar, like 16 tons an acre, 32 tons an acre, right? Like crazy amounts. And we haven't seen yield declines. But again, I would just encourage anybody who's applying anything to their soil to think about how the components of that soil amendment are going to affect your soil physically and chemically. Yeah. And again, my advice is always start small, right? You can always add more. So if you add 1 ton an acre and then you're like, well, I'm either not seeing anything, or I'm doing another soil test and I'm not where I want to be, you can always add more. But with biochar, it's not compost. It's not going to degrade. It's not fertilizer. It's not going to be mineralized. It's just, so yeah, just be careful. And, you can also use our tools online at pnwbiochar.org to kind of figure out, what the fertility consequences of a specific application might be.
Right. And Kristen, those fertility consequences are both nutrient content and availability, but also pH changes, right? And so that's one of the ones that's foremost in my mind, is if you apply a biochar that is very high pH, it's got a certain liming equivalent. I imagine there's probably some upper level where you don't want to go past that, or you're going to end up with really high pH soils. Is that right?
Yeah, like my dad, puts lime on his lawn every year. And finally, last year, I said, "What's your pH?" And he's like, "I don't know." And he looked and it was like 8.5. And I was like, "Dad, back the heck off. Like, you don't need lime. You're good." And so, yeah, look at the pH of your soil, look at the pH requirements of your crop, look at the calcium equivalent, calcium carbonate equivalents of your biochars, and don't make decisions that are really difficult to reverse.
Absolutely. Well, there's so much more we could talk about. If you want to hear more about that tool, Kristen gave one of these webinars. It's one of the first in the series. If you want to hear more about production, there was a great webinar early on in our series about production systems all across the country. If you want to hear more about application, there was a great one about how to apply biochar and some of the ins and outs of what to do and not to do. But with all of that, I'm sure there's a lot more we could tackle. So if any of those still hanging on, we've still got 27 participants. That's excellent. Thanks for hanging on so long. If you have any other thoughts, do fill out the survey. That's how we collect your thoughts on what else we should tackle. And we will keep up this webinar series. So really excited to keep that going, learn from all of you, see what questions are out there. So I want to say thank you again. And I'm going to close this out. Thank you all panelists who hung around and everybody else, all the other hosts who chimed in. Really great talking to you, really fascinating stuff. And we will see you next time. Look out for the next webinar that's going to get announced. Take care all.
Thank you.
Thank you.